Bienvenido a Café Espacial. Conduce y dirige el doctor Fermín Romero Vázquez. Análisis con expertos en materia sobre el futuro de la agenda espacial global, así como las diversas temáticas inherentes a la exploración espacial, los beneficios de la ciencia y la tecnología espacial para toda la sociedad y los problemas derivados de esta en términos de desarrollo para mejorar la calidad de vida en la Tierra y su potencial extensión a otros confines del universo a través de la nueva carrera espacial y el New Space. Café Espacial. Es momento de un café.
Romero again, and it's good to see you in this episode 10, 16th season. And we are very glad to have two very important people with us. They are Annesha Mazumdar, founder and CEO, lead architect of Space Nova, and Abdelrahman Shahin. Annesha is the founder and CEO of Nova Aerospace Initiative Developing, which is a next generation autonomous flight executive engines operating from Calcutta. She boosts the architecture of the development of autonomous deterministic executive layer, ADEL, C++ force onboard runtime engine designed for zero latency, collision avoidance, and satellite asset protection in LEO orbit, LEO. Her work focuses on bridging the ground telemetry latency gap and enabling edge executive real-time trajectory optimization directly on satellite onboard computers. Annesha led Space Nova international partnerships across global space safety and orbital sustainability initiatives. Abdelrahman Shahin is an aerospace engineer graduated from New Mansoura University in Egypt. He specialized in aerospace systems, spacecraft, and unmanned aerial vehicle design. His research focused on microsatellites, attitude and orbit control systems, AOCS, and advanced propulsion technologies. He's passionate about innovation, space exploration, and emerging aerospace technologies. And his goal is to contribute to developing the next generation space navigation systems. The subject of today is closing the latency gap, how ADEL secures LEO operations, eliminating collision risks. In the era of mega constellations and exponential satellite deployment, the challenge of maintaining safe and sustainable operation in LEO has never been more urgent. Closing the latency gap in LEO explores how autonomous decision layers like Space Nova Autonomous Deterministic Executive Layer ADEL is redefining the boundaries of orbital safety by eliminating communication delays and enabling real-time collision avoidance directly at the edge. The paradigm marks a decisive shift from reactive group-based control to proactive self-governing constellation. It is not just speed, it is about certainty, resilience, and the future of space autonomy. To start, we are going to start with Abdel, and I want to ask you, Abdel, communication delays between ground stations and satellites create dangerous blind spots. Would you illustrate a real-time world scenario where latency represents critical vulnerability in low Earth orbit and LEO Earth orbit operations and directly endanger the missions?
Okay, yeah,
Yes.
sure. Is a question for me or for Annesha?
Yeah, you Abdel.
Okay, so for starters, let me give an example for a real-world scenario for how communication delays are really critical and may cause vulnerability in the space field. Okay, in 2009, there was a collision between two spacecrafts, Iridium-33 and Cosmos 2251. The two spacecraft collided in the low Earth orbit at roughly 7.5 kilometers per second. Relative velocity destroying both of the spacecraft. They vanished in space. They turned to space debris. So the event demonstrated a fundamental space awareness or spacecraft self-awareness problem, conjunction detection, and assessment coordination, and maneuver execution. Because of the dependencies on the ground control base or the ground systems that humans communicate with the satellite, and they analyze the data coming from the satellite, then they respond back. So that causes a latency. Latency is the time that it takes from the communication between the satellite and the ground station and the returning time and the action. So basically, autonomous systems just like erases all of that time. The autonomous systems, they rely on 3 steps: sensing, cognition, and action. So the first step, sensing, is already in the satellite, the sensors, the GNSS, the IMU, all of them components. And for the action, we have the actuators, the magnet torquers, the reaction wheels, the thrusters. So it comes up to the cognition part, where we depend on the human-based or the ground-based connection, which causes some vulnerability, as we mentioned before. So autonomous solution, as mentioned, the ADEL system, will help us reduce all of the negative parts of the latency part.
Right. ADEL software uses TLE with math models like SGPA4 to predict a satellite's future location. How does the TLE decay directly impact the accuracy of conjunction assessments, and how does ADEL compensate for this decay compared to legacy methods?
Okay, basically, a TLE is essentially a snapshot of the satellite's orbital state at a specific epoch. As time passes, perturbations such as atmospheric drag, especially in the low Earth orbit, in the LEO, cause the actual orbit to diverge from the orbit predicted from the latest TLE. Using the SGP4, this increases position velocity uncertainty, particularly along track. So you have an outdated data from the satellite's location, and when it takes time to go back to Earth, and then you send the action back to the satellite. So all that takes time. The SGP4 is a model where they use prediction of the collision. It predicts or it predicts a number, or quantifies the collision's probability. So ADEL can compensate that part. We're not gonna vanish the SGP4, or we're not gonna vanish the Foster's probability technique, but we're gonna integrate it with the ADEL part. So compared with a legacy ground-only approach, the key advantage is continuous onboard state awareness rather than dependencies on the age of the last catalog update.
Right. Again, Abdel, why traditional SSA workflows struggle to keep pace with the modern constellations dynamic, and what is the biggest bottleneck you see in the current SS networks?
Shall I answer?
Yeah. Oh.
Okay, so thank you for the question. So I want to continue this by saying, Fermín, that already Abdel has given a bit of explanation what our ADL is. And now I will tell you why our legacy SSA, space situational awareness, built for with just few hundreds, was actually built for few hundred satellites. But today, with thousands of mega constellations launching at the ground stations, are overwhelmed with the current kind of telemetry. Due to thousands of satellites are being launched, but actually the era was about for few hundreds of satellites. But now it's actually more than thousands of satellites, which is crowded our LEO Earth orbit. So therefore, the biggest bottleneck currently, which we see to ground to space communication, the gap which is lying between we cannot merge real-time orbital traffic management using delayed and on ground-based approvals. We cannot wait on what actually delay on their ground-based data or telemetry data.
Right. Well, As CEO and founder, Annesha, please tell us what inspired the creation of Space Nova and ADEL architecture.
I'm sorry, can you just repeat once again for me?
Yes, I ask you what inspired the creation of Space Nova and the ADEL architecture.
Just the voice is cracking, I think.
Okay, no problem. I ask you what inspired the creation of Space Nova and the ADEL architecture.
Yes, I can hear now properly that what exactly inspired me to create the ADL, our autonomous deterministic executive layer. Am I correct? Yeah. So Space Nova was born from an idea with a simple question in my mind. So I had a kind of a research on the bottlenecks or the challenges our LEO Earth orbit is currently facing. So a single idea has born Space Nova or our ADL product, where today with thousands of mega constellations as crowded, our question was why rely on ground station hours away when the satellite has their own computing power on board. So we engineered our own ADL, our own autonomous deterministic executive layer, to give satellites instant self-preservation capability right at the edge, shifting the industry from panic to proactive autonomy. That was our main plan or main idea to create the architecture behind Space Nova and how it's fundamentally going to create a global impact for all the LEO Earth infrastructures around the globe, not only for India or specific for any country. We need to keep our Earth safe, the Earth orbit safe. So that was my first idea to create or to actually give birth to this idea or this project. Thank you.
Right. Well, let's move into the technical deep dive. Foster's 1992 model relies on probability. ADEL offers certainty. Yes. How does ADEL deterministic layer differs from probabilistic collision model like Foster 1992?
Okay, yeah. So Foster's approach calculates the probability of collision, as I mentioned before, based on the predicted relative trajectory and its uncertainty. In other words, it answers a question. The question is that what I know and the associated uncertainties around me, how likely is a collision? It's a percentage. Maybe it's going to be like I might collide with a 90% rate, or maybe lower, maybe higher. But the difference between the Foster's 1992 probability and the ADEL's deterministic layer, the ADEL deterministic layer answers a different question. Regardless of the calculated probability, has the spacecraft entered a condition that violates a predefined safety constraint? How bad is it? That's what ADEL tells you. For example, ADEL can define a deterministic safety boundary around the spacecraft. If the predicted trajectory violates that boundary, the safety layer can trigger a response according to predefined rules. So the action starts, as we said, in autonomous systems. The last step in the autonomous system is an action. So here it happens. The ADEL system gives like after the calculations and all of that, gives you the action right away. It doesn't wait for the response from the ground control base. So ADEL doesn't necessarily replace probabilistic models. These two can work together, actually. Probability helps to quantify the risk, while the deterministic layer establishes hard safety boundaries and autonomous responses. I would avoid saying ADEL provides absolute certainty of collision avoidance. A stronger technical claim is that it provides a deterministic decision logic under predefined safety constraints. So it optimizes the action and it reduces the time taken to act.
Right. Again, you, Abdel. How does ADEL achieve zero latency in maneuver execution?
Okay, yeah, strictly speaking, there is nothing with zero latency. There has to be sometimes, like it may, like we can get really close to zero, but there's no absolute zero. But ADEL's advantage is eliminating the ground communication latency from the critical decision loop. A traditional process could be detection, ground transmission, which takes time, SSA analysis, human doing some work on a computer or having responses, then a human decision, then a command uplink, spacecraft maneuver. Like we can count 5 steps in what I said. And the two of those steps are human factor decision. But ADEL changes this to detection, onboard assessment, and maneuver, like 3 steps only. So the spacecraft can therefore respond within the limits of its onboard processor, sensors, and actuators without waiting for a ground command. So I would describe it as ADEL enables a near zero communication latency by keeping the critical safety decision and maneuver authorization on board.
Excellent. Annesha, can you explain the right of weight hierarchy and how it prevents double jump collisions?
Yes, Fermín, if 2 active satellites drift into collision path, both the dodge itself, both comes and dodge in the same direction, they create a double jump collision. So our ADL, our autonomous deterministic executive layer, prevents this using deterministic right of way protocol. Lower priority assets yield or execute evasive maneuvers, while higher priority assets, the industry from reactive panic to proactive autonomy and ensuring guaranteed separation. And by this, we hold the asset for their course of action of time.
Great. Abdel, how
Yes.
does the thermal variance layer mitigate? And with you, please. How does the thermal variance layer mitigate GNSS signal drift and hardware noise?
Yeah, that's a really good question. And as an aerospace engineer, I really understand how the thermal variance in space is really critical for spacecraft, especially that you have one side of the spacecraft facing the sun at like 120 degrees Celsius degree,
Yes.
affecting the radiance is affecting all the chips and all the processors inside, and the other side is facing deep space, which is really cold. So temperature variation can affect spacecraft electronics and sensors. For example, thermal changes can introduce oscillator drift, sensor bias, and increased electronic noise, which can indirectly degrade the GNSS-based navigation. So ADEL's thermal variance layer monitors the relationship between temperature and expected sensor performance, especially that you have the data sheet of every component on the satellite and you measure the temperature in space, so you can build a relationship between them, and ADEL offers that. If the spacecraft experiences unusual thermal conditions, the system can increase the estimated uncertainty of affected measurements. Rather than blindly trusting them, it's not just going to take the measurement and say, yeah, let's act upon this reading. No, it's going to wait a second, and this second it will see, is this measurement true or not? If it's true, or if it's how close is it for true? Is it true? And if it's really far from truth, then we would have another reading and we will see what's drifting the readings from the sensor. For example, temperature instability, if it rises, so expected sensor uncertainty rises, so the measurement weighting goes down. So you have to fix that. So the navigation filter can then rely more on other valid sources, such as the IMU, or the magnetometers, or previous state estimates. There's a library on the satellite that can help you with all that until the sensor becomes reliable again. So the layer doesn't magically eliminate GNS noise. No, it just finds solution for it. It makes the navigation system aware that thermal conditions may be degrading the measurement and adjusts its confidence accordingly. And engineering, we always know that there's an uncertainty. There's a percentage of uncertainty in every dimension we have, or every reading we get from a sensor. But instead of just neglecting that uncertainty, we find a way to compensate that.
Great. You and Annesha are so young, and it is really great to hear you talking about these technical issues. I want to ask you before to go to the short break. Is there a book or a novel about space that sparked your interest in astronautics?
Is this question for me, Fermín, or for
No,
Abdel?
it's for Abdel. First
Okay.
Abdel.
Come again, sorry. I didn't hear.
Yeah. Is there a book or a novel about space that sparked your interest in astronautics?
There's a novel, what? Sorry?
There's a book or a novel about space that sparked your interest in astronautics.
Yeah, sure. I've loved the space sector since I was a kid, actually. Like I've read the 2001 Space Odyssey for Arthur Clarke. Was he Arthur C. Clarke? And it actually inspired me, like reading about evolution and seeing how like space is great and it's the future. Actually, this Zoom meeting we're in or this podcast we're in wasn't gonna be able to like wasn't going to be here if there wasn't space technology, if there weren't satellites, if there weren't internet, all of that. So the book inspired me. A lot of inspiration came to me as a child. That's why I pursued having an aerospace engineering degree. It comes really long way, you know, since I was a kid.
Right. What about you, Annesha? The same question. Is there a book or novel about space that sparked your interest in astronautics?
Not specifically book. I have not yet read specific books regarding to space or astronomy, but yeah, I have watched sci-fi movies like science fictional movies such as the Interstellar. That was a very, very big point of my like inspiration kind of a movie. There was a part of the movie I would like to say in short where Murphy was the kid who had made a law that anything which will happen will happen. So that is what gave me the inspiration today to create ADL. As soon as we looked for the problem, we did not sat with the problem and rather look for the solution. So anything from that movie, anything what we have happens will happen. So our hope is to build a brighter future for the generations to come, make our orbit safety for future generations to see and feel the same feelings we and Fermín or Abdel is now having. So yeah, movies have been a very inspirations to me into this world. And since childhood, my parents, my sisters have given me an extreme different kind of faith and leap of faith towards the universe. So I am a bit connected. I am not technical. I'm not at all into technical stuff, and I am a commerce graduate student. So I really do not have a aerospace engineering knowledge, and this creation was a big deal for me because I have to architect everything, learn orbital dynamics, learn how the orbits are moving, how these maneuvers are happening, what is delta V, propulsion, and everything I have to learn from the code to create this. And today, after I have received partners and people, different people from space ecosystem coming forward, helping me. Today, our partner from Gregorio, he's from ex-ESA veteran. He's part of our Space Nova community team. And today he's not with us, and I really feel his absence because he's in some kind of emergency meeting with his family. So this kind of people came out, they validated my work, they understood my challenges on what actually I want from, what is my vision. They understood my vision and they helped me to create what ADL is today and how it is becoming a safety wrapper for all the orbital infrastructure. So yeah, movies have given me immense faith and motivations to actually step into this world. Even my parents did and my family did. So yeah, thank you.
Thank you to you, dear Annesha. Well, let's go to a short break, and then we will continue talking on these important issues, particularly the software you
Yes.
develop, ADEL. But right now, let's move to a short break.
Sure.
México, te quiero despierto, te anhelo vibrante, te pienso fiel, latiendo al ritmo de tu recuerdo, camino en el renacer. Corazón de maguey, corazón de maguey, mil mentes son más de mil razones buenas, la tradición, el color de la luna nueva,
pronto conocerás el alma de Querétaro. Las manos y los corazones que mantienen con vida y en movimiento a nuestra ciudad. Yo soy Juan Pablo Araujo y esto es Querétaro Vivo.
Well, we're coming back to talk with these two young people who are very happy to announce this software. So I want to ask you about the operational and economic impact, and let's start with you, Annesha. How does ADEL reduce propellant expenditure and extend satellites lifespan?
Yeah, so that is a nice question for me, I must say. So ground operators often trigger large panic-driven thrust maneuvers due to delayed data. Our ADL operates continuously hourly basis in advance, calculating micro thrust pulses that consume up to 90% or less delta V fuel. Saving this fuel directly extends a satellite's commercial lifespan and operational return of interest, I believe.
Right. And
Yeah.
how does Space Nova's SAS and PAS model transform the economics of flight software?
Yes, so as a Space Nova as a software as a service or as a platform as a service model transform the economic of flight software totally, because custom flights control software used to cost million in upfront capital expenditure. But Space Nova shift this to a major SAS or PAS module, operates license ADL on board as a operational expanse, OPEX, scaling autonomy across 1 or 2 thousands of satellites seamlessly.
Right. And what are the licensing tiers and how do they align with different mission profiles?
Yeah, we actually offers flexible tires, basic safety layer for standard CubeSats, and also for autonomous fleet tire for mega constellations, and defense or sovereign tire for high security, and ultra low latency assets required strict compliance. As of now, we have planned.
Yeah. Well,
Yeah.
well, thank you. Let's move to the strategic and ethical dimension, and this question is for both.
Okay.
Let's start with you, Abdel. What are the ethical implications of removing humans from the decision loop?
Okay, that's a really nice question, actually. Everything we do is to serve humankind or to serve mankind, okay? So we can't 100% rely on AI or autonomous systems to take over. Especially if I'm telling you right now you're on an airplane who has no pilot, that plane is flying itself. How would you feel? You would feel a little bit concerned. So what we're trying to make is that we can make it easy for humans to make decisions by showing them every decision and its consequences and like that. So humankind or mankind are going to be in the decision loop of spacecraft controlling. Everything is made to serve the humankind, but we're just making it easier for humankind to develop and to make and to build and to see and to make decisions. So the autonomous sector, okay, you're making the time go much less than like if you had a human in the loop. But at the end of the day, there's priority for humans. Like even in the manufacturing sector, in the cars and everything like that, in the automobiles, the factory has a whole robot that can build the car from scratch. But at the end of the day, a human has to verify that the car is safe and they can operate. Same thing in satellites, same thing in rocket ships, same thing in everything like that has technology in it. So we're not going to remove the human from the decision loop. We're just like enhancing the or optimizing the operation. That's it.
Great. It's good to hear that. Same question for you, Annesha. What are the ethical implications of removing humans from the decision loop?
Decision loop, right? So autonomy does not means removing human accountability totally. It means trusting deterministic safety bounds. ADL operates under a tripod trust matrix. Actually, we have specifically put this tripod trust matrix because we did not wanted to remove the human decisions from the software itself. Our plan was that tripod trust framework here, humans set governance rules and safety envelopes, while onboard software executes zero latency maneuvers fixedly within those parameters. So we are not actually cutting off the entire human from the loop. We are just making our product more advanced so that humans are required when there the system goes into that kind of crisis, when the confidence level of the satellite or the onboard camera computer or the software itself lies below 75% of threshold. That moment, the confidence level, when it is going beyond their criteria of the software, then it is transferring again the data back to the ground operational people who is at the ground. So we are not at all removing the humans from the loop. Human is essential. He's the humans are the important part who is governing thing. But we are creating some kind of like relief for the ground people, so that in the maximum more emergency crisis situation they can come in, and maximum time the maneuvers can be decided by the satellites itself and human does not require them. So that is what our plan is.
Excellent. Talking about accountability, how does ADEL show accountability in autonomous maneuvers?
Every single maneuver decisions which we have made, I hope I am audible, right?
Okay.
So yeah, am I audible?
Yeah.
Because so every single maneuver decisions and telemetry shift is logged on board into a tamper-proof execution and audit trail. So ground operators receive complete post-maneuver telemetry data as soon as contact is re-established.
Okay.
I hope that answers. Yeah.
Right. Again with you.
Yeah.
ADEL integrate with international SA networks to enhance global space safety. Can you hear me?
Annesha, I think, can you hear the question?
No, I cannot hear the question.
I will repeat it, no problem. Could ADEL integrate with international SA's network to enhance global space safety?
I think I'll answer it. There is some voice issues or something.
Okay.
I can answer if there's no problem.
Yeah, go please.
Okay, yeah. So absolutely. Like you said, if ADEL can integrate with the international SSA networks, sure. In fact, it should be a core design principle of ADEL. ADEL could receive external conjunction and tracking information from international SSA networks while combining it with the spacecraft's own onboard navigation and sensing. So the architecture could be like international SSA networks, then the ground data, then ADEL. Combined with the sensors on the satellite itself, the GNSS, the IMU, the magnetometer, the onboard sensors, sun trackers, every sensor on the satellite. In addition to the libraries, like you can build the library of all the data and all the scenarios that could happen, and that library would make the latency less and less, and will take less computational time. So this creates a hybrid safety architecture. Global networks provide the broader picture, while ADEL provides immediate local decision making. So you get the best of both worlds. You get the big plan, the strategic plan, and what they call the end view plan. So you're in the field at the same time, you know the big plan, what it is.
That's
Yes.
right. Okay, well, I'm aware that you are not experts or space lawyers, but I think this question is very important, and I want to ask you both. And let's start with you, Annesha. What
Yes.
governance frameworks are needed to regulate autonomous orbital systems?
Yeah, the space sector urgently needs standardized rule of the road for autonomous and space traffic management, defining clear right-of-way rules, standardized collision probability metrics, and open data protocols to cross across operators and agencies. So I think the governance frameworks are needed to regulate autonomous orbital safety at the earliest.
Right. And what about you, Abdel? What governance frameworks are needed to regulate autonomous orbital systems? Let's talk about space traffic management, by example.
Sure. In my opinion, governance needs to develop alongside the technology. The three areas are particularly important. First, the rules of responsibility. Second, common technical standards. And third, certification and auditability. For the rules and the responsibility, there must be clear definitions of who is responsible when an autonomous system makes a maneuver. Operator or spacecraft owner or software provider or another party. Who is going to take the blame if a problem happens? Yeah, God forbids. The second thing is common technical standards. Autonomous spacecraft should follow standardized protocols for conjunction information, maneuver notifications, right-of-way and collision avoidance behavior. So independently developed systems can developed systems can cooperate. Third of all, certification and auditability. Autonomous safety systems should be tested and certified against predefined scenarios. Actually, that's what validation comes to when you have a AUCS testbed, if you have a thermal vacuum testbed, or every test that NASA or ESA or ESRO, even the Egyptian Space Agency conducts on the satellites before launching, that is really important because you simulate the scenario before it happens. So
Yes.
I would say that there should be a human accountability, a machine autonomy, and international Interpol that could define these rules and make the space sector even better.
Yes.
Okay, let's talk about the vision and the future outlook. Annesha, in the age of new space, what's next for Space Nova? I mean, the future roadmap in terms of constellation scale deployment.
Yeah, so Space Nova's roadmap focuses on scaling our ADL across mega constellations while collaborating with space agencies like ISRO, Indian Space Research Organization, NASA, and ESA. By combining agency situational awareness with Space Nova's onboard deterministic engine, we make LEO operations safe, sustainable, and self-protecting.
Right.
Yes.
Abdel, how do you envision collaboration between startups and space agencies like NASA, ESA, or ISRO in India
Okay.
in deploying ADEL to secure LEO sustainability?
Okay, I envision a three-layer collaboration model. Startups would provide the innovation. Because startups are more agile, they don't have all the routine work, so they have innovation. Dell software, autonomous algorithms, onboard safety systems, and rapid technology development, not just from Space Nova, from any startup in the space field, that would help. They're like new, passionate in the market, so they would find solutions for the small stuff. Space agencies such as NASA, ESA, ESRO, or even the Egyptian Space Agency, as I'm from Egypt, they could provide validation environments, mission data, testing infrastructures, regulatory expertise, as we mentioned in the law of space, and opportunities to demonstrate ADEL on government missions. They can, they can deploy ADEL right away on any of the satellites they have, and they could see the expected results. Finally, international standardization would be essential. Agencies and commercial operators could establish common protocols for sharing conjunction information. You don't have to own the information for yourself. You can find a protocol to help and conquer. Maneuver intent and right away rules. Startups, as I mentioned before, startups bring agility and innovation. Space agencies bring validation, infrastructure, and standards. Together, they can move the low Earth orbit safety from a reactive ground-based model toward a cooperative autonomous ecosystem.
Excellent. Annesha, we know you're planning to expand your operations to Latin America. Can you tell us what exactly are your plans to operate in Latin America and how?
Yeah, so thank you for asking this question. I think this is the most important question of the podcast. As Space Nova expansions roadmap for ADL 2.0 across Latin America, and no, Latin America consists of 30 countries, sovereign countries, on capturing market share is rapidly booming. The space industry market is rapidly booming in the Latin American countries, and regional space economy through targeted software licensing and strategic regional advisories and institutional agency alignments we are currently focused on. So our first important thing is that we want to market integration and regulatory frameworks. We want to focus on this part, because capitalizing on Latin American space growth, which is the most important thing, because Latin America is establishing its unified space architecture through the Latin American and Caribbean Space Agency, alongside to this active regional agencies like AEM Mexico and AEB Brazil and CONAE Argentina. So we are focused to set up our own strategic baseline in this part of the Latin American countries. Also, we have focus on commercial and DevSecOps partnerships. Our ADL 2.0 is designed as a fully containerized C++ Rust engine telemetry software platform. So partnering with regional leaders like such as Lugapel in Uruguay allows ADL 2.0 to integrate directly into multi-source integration pipeline and offer age-based trajectory safety at the earliest. So, and also we are looking for institutional advisory and leadership from you as well, regional board representatives like for our ADL. Through the strategic board alignment of Fermín Romero Vázquez, president of FAU and CI Consultoría institution access to regional space agencies and government space portfolio and trade delegations across Latin America. Also through educational and media positioning, because leveraging platforms like Café Espacial series serves to broadcast ADL's deterministic age autonomy features to aerospace universities, facilities, and also satellite operators and research institutes like across LATAM. So we are focused totally currently on enterprise plus go-to-market and licensing tiers. So which is totally in pure software licensing as a SaaS model, in software as a service or platform as a service. Space Nova provides LATAM operators with a flexible, low capital capex software licensing model. Regional operators can integrate the ADL runtime onto satellite onboard computers without building custom safety software from scratch. And also we are focused on dual use of sovereign safety tiers, the roadmap to target both commercial non-satellite fleets and sovereign orbital assets, delivering the microsecond deterministic collision avoidance, which will add up to 90% fuel saving without reliance on ground latency. So this is our basic plan or roadmap for our expansion in Latin America. Thank you for introducing us, me and my team, which you are also part of it now. I'm happy to say that. And also Gregorio and Dr. Murthy from India. He's an ex-ISRO veteran. So we all are so happy to actually establish our footprint into Latin American countries, and we are here to serve for the nation and make our orbital our safety for the future generation. Thank you, Fermín, for this opportunity.
Thank you to you, Annesha. It's for me and for my partner, Dr. Mateo Martinez in Uruguay. It's a pleasure to analyze this
Yes.
possible alliance. We are starting analyzing it, but we are sure that there's a high probability to start these operations in Latin America.
Yes.
Abdel,
Yes.
what about you? What are your expectations from Latin America? Talking about this, Annesha, explain us.
Yeah, sure. For me, I think that Latin America has an opportunity to build space sustainability into its growing satellite ecosystem from the beginning. So rather than replicating a purely ground-dependent SSA model, ADEL could provide provide a collaboration between the autonomous safety layer for emerging LEO operations or operators, and at the same time the ground-based or the ground-dependent SSA model. So developed through partnerships between regional startups, universities, space agencies, and international organizations. This could make all Latin America countries like Mexico, Brazil, Argentina, Colombia, particularly relevant countries to explore for Space Nova partnerships. They could expand their the local startups and local market. They could start exploring this, and they could start having expertise like consulting with them, and this would be a really strong beginning for or not a strong beginning, a strong push or a strong it's gonna make it boost in Latin America's space market, especially. As we know, even in Egypt, we're still new in the space market and the space sector, but we developed through foreign expertise and international protocols. And at the same time here, the universities, we started making aerospace engineering sectors in the universities. A lot of startups are showing up for space technologies. For my graduation project, in fact, was an ADCS test bed. So all of that, we're working on it, and I see that Latin America can do more actually, and can develop more and could exceed a lot of other space agencies.
Yes, thank you. Well, we are pushing that issues here in Latin America because, as you mentioned, not too much countries are working on this, but it is really important that the full region start to work on these things.
Yes.
Well, I know you are very focused on orbital operations, guys, but let me ask you, if you could join a space mission, which destination would you choose? The moon, Mars, or beyond? Let's start with you, Annesha.
What was the last option? Moon, Mars,
or beyond?
Beyond.
Sorry?
Beyond.
Somewhere else.
So somewhere else. Even I am not aware of this name yet, but you asked me that if I get to part of one mission, which I got to understand, one is moon and other one is Mars. So I'm definitely going for the Mars mission, because Mars has been, the gravitational force of Mars has been pulling a lot of tragic happenings for Earth, and it is our neighbor planets, and I have seen new videos coming from Mars every day from NASA. I can see on my post, gives me more inspirations to know that what exactly Mars have more for us. I know there are many lunar operations are happening from ISRO, NASA, and different space agencies. but I would love to go be part of the Mars mission, because I have been following deeply with the NASA's research, and the recent photos came out, the viral pictures, which shows that there might be some civilizations which were there present long time ago, because the scientists and the researcher from NASA have recently found some footages where they have found some elliptical shaped stones or architecture things which they think which is not possible or natural, cause it cannot happen. There must be a man-made or a human intervene into that. So those things had create a kind of inspiration towards mystery, because I am pulled towards mysterious things into the nature or space, and space is mysterious. We are very much curious to know more about space. We hardly know half or less than half about space, and there are more things about space to research and know. So yeah, I would definitely be part of the Mars missions to know that is there some humans or other kind of living extraterrestrial beings who were actually present on the Mars. So yeah, I'll be part of that Mars mission.
Thank you.
Thank you.
What about you, Abdel? If you could join
Okay.
this mission, which destination would you choose? The moon, Mars, or beyond?
That's a really nice question, actually, because I would like to visit all of them, but I have two answers.
Okay.
I have a
How
logical
you
answer and
decision?
yeah, yeah. I have a logical answer and I have a fictional answer. For the logical answer, I would like to, as Annesha said, I would like to go to Mars, explore around there, and actually, it's gonna be like a good opportunity to see another planet. I would also like to go to the moon because it's really great that a place that you've been looking into the sky and seeing it all of your life, and you're just there right now. No one else is just for a few people got there, so it's gonna be really nice. As for the fictional part, and I like get it from the Interstellar movie. I would like to go to see a black hole. I would like to see how it is in real life and all the physics about it, and I would like to
Yeah.
study it more. So yeah, that's my answer.
Okay. Okay, before to finish this talk, I want to ask you, please give us a final reflection on this talk. And let's start with you, Annesha, please.
Yeah,
Uh,
so I am so glad and I am so privileged I feel today, because I would like to add a bit that today is our Independence Day and we just celebrated our 80th Independence Day in India. And I'm so happy that I got this opportunity as an Indian to represent my country to Latin American countries with my product. So it's a huge privilege and opportunity for me, and I am so much happy to be part of these discussions. We got to learn about what ADL is and how it's going to protect our future mega constellation satellite companies and our infrastructures, orbit infrastructures. At the same time, we actually got to speak with Fermín over a live podcast. That is a huge blessing for me today, and I'm very happy and I'm looking forward to be part of this Latin American more projects. I'm looking forward to endorse my projects and my achievements or my whatever impact I can put towards the Latin American country. I will try to do from my end, and I am very happy. Thank you so much, Fermin, and I'm really grateful.
Thank you, dear Annesha. And Abdel, what about you? Give us a brief reflection on this talk we have.
I would like to thank you, first of all, for having you on the show. It was a nice opportunity, and it's really nice meeting you. And as Anesha said, as she wants to explore the space sector and to expand and the good thing about space is that there's no borders, there's no limits. Everyone is a friend. So
Right.
we collaborate internationally in space sector. So that's what we're trying to do also in Egypt. And actually, it was a really nice opportunity to get to know Annesha and to get to know you, Mr. Fermin, and to collaborate with you on this. And I hope for a great future in the space sector and in every other life aspect to be great and to be honorable. and I hope that we could like meet again, hopefully, and we could find some great projects to work on and to boost up the space sector and to have a lot of meaningful contributions in this sector. And thank you very much for having us. It's a really big honor. Thank you very much.
Yes. Thank you.
It's my pleasure. Well, just to finish, as we look toward a more crowded and interconnected orbital environment, the ability to act instantly and deterministically will define the next generation of space operations. Closing the latency gap in LEO reminds that autonomy is not the absence of control, it's the evolution of control. Through architecture like ADEL, we move closer to a world where constellations work themselves, where latency no longer dictates risk, and where collaboration between innovators and agencies ensures that the space remains a domain of safety, sustainability, and shared progress. Thank you so much, my dear guests.
Thank you very much.
And
Thank
let's
you.
continue talking, okay? Thanks to everyone.